management. And today we are going to discuss memory hierarchy. Memory hierarchy. The memory in a computer can be divided into 5 hierarchies based on the speed as well as the use. The processor can move from one level to another based on its requirements. The 5 hierarchies in the memory are registers, cache, main memory, magnetic disks, and magnetic tapes. The first 3 hierarchies are volatile memories, which mean when there is no power and in actuality, they automatically lose the stored data. Whereas the last 2 hierarchies are non-volatile, which means they store the data permanently. A memory element is the set of storage devices which stores the binary data in the type of bits. In general, the storage of memory can be classified into 2 categories, such as volatile as well as non-volatile. The memory hierarchy characteristics mainly include the following. Performance. Previously, the designing of a computer system was done without memory hierarchy, and the speed gap among the main memory as well as the CPU registers enhances because of the huge disparity in access time, which will cause the lower performance of the system. So, the enhancement was mandatory. The enhancement of this design was based on memory hierarchy model due to the system's performance increment. Ability. The ability of the memory hierarchy is the total amount of data the memory can store. Whenever we shift from top to bottom inside the memory hierarchy, then capability will automatically increase. Access time. The access time in the memory hierarchy is the interval of the time among the data availability as well as the request to read or write. Because whenever we shift from top to bottom inside the memory hierarchy, then the access time will increase. Cost per bit. When we shift from bottom to top inside the memory hierarchy, then the cost for each bit will increase, which means an internal memory is expensive compared with external memory. Memory hierarchy design. The memory hierarchy in computers mainly includes the following. Registers. Usually the register is a static RAM or SRAM in the processor of the computer, which is used for holding the data word, which is typically 64 or 128 bits. The program counter register is the most important as well as found in all the processors. Most of the processors use a status word register as well as an accumulator. A status word register is used for decision making, and the accumulator is used to store the data like a mathematical operation. Usually, computers like complex instruction set computers have so many registers for accepting main memory, and RISC-induced RISC instruction set computers have more registers. Cache memory. Cache memory can also be found in the processor. However, rarely it may be another IC, integrated circuit, which is separated into levels. The cache holds the chunk of data, which are frequently used from main memory. When the processor has a single core, then it will have 2 or more cache levels rarely. Present multi-core processors will be having 2 levels for each one core, and 1 level is shared. Main memory. The main memory in the computer is nothing but the memory unit in the CPU that communicates directly. It is the main storage unit of the computer. This memory is fast as well as large memory used for storing the data throughout the operations of the computer. This memory is made up of RAM as well as ROM. Magnetic disks. The magnetic disk in the computer are circular plates fabricated of plastic, otherwise metal, by magnetized material. Frequently, 2 faces of the disk are utilized, as well as many disks may be stacked on one spindle by read or write heads obtainable on every plane. All the disks in the computer turn jointly at very high speed. The tracks in the computer are nothing but bits, which are stored within the magnetized plane and spots next to concentric circles. These are usually separated into sections which are named as sectors. Magnetic tape. This tape is normal magnetic, according to which it is designed with a slender magnetizable covering on an extended plastic film of the thin strip. This is mainly used to back up huge data. Whenever the computer requires to access a strip, first it will mount to access the data. Once the data is allowed, then it will be unmounted. The access time of memory will be slower with a magnetic strip, as well as it will take a few minutes for accessing a strip.